Okay, I think that we are going to start. So welcome, my name is Kai Niemi and I'm very pleased that we are hosting as Eficode today this Finland AZURE user group meetup here at Tampere. It's a warm thing that we are all here, and of course you guys there and ladies out behind the stream. So Eficode, we are doing the via DevOps things, building the software area, topics, and doing the amazing things. But today we are going and reaching out of clouds. So please, Carl, invite us there. Thank you.
Thanks. So I think I'll do a quick introduction of our speaker set here as well. So hello everybody, my name is Carl Otz. I will be also doing the first speaker set, so I will be introducing myself and I a little bit more later as well. And I'd like to do some highlights here for our speakers. So after me there's Annie, going to talk about there she is, you might not see her on the stream. Then there's Teemu as well, and before Teemu, I believe, do we have the last speaker here as well? Yes, you are. Yeah, like no reaction. I was like, no, yes, maybe, yes. Okay, so we're all here, which is always good. I think the no-show rates are a lot better here than in the capital area that we are doing this. So this is always a good surprise as well. We even have some free seats left, which is always good for some introverted folks here. And also great for the great to see the stream. The quality seems very good here, so there's definitely some competition among the Tampere meeting hosters related to the FAUG as well. So I'm hoping that next time there's like a professional makeup and all of that as well. And let's see if all of this works and how this works. So yes, we are here at the Finland AZURE user groups Tampere meetup number 3, and all of these have happened during this year. This is actually our first AZURE user group event after the summer break at all. So this is also the first any FAUG meetup after this summer hiatus, and we'll have a lot of events coming up later as well. But for those who are not really familiar yet with Finland AZURE user group, our idea is that we bring our common interest toward cloud computing and specifically the Microsoft Azure platform together, and we host quite a lot of regular meetups and some ad hoc extra larger events also in Helsinki area, and then we do also have quite a lot of regular meetings here in major cities of Finland, and we've all even been to outside as well, like we've been once even to Turku. And we've also been to some smaller other cities as well. And we have different other types of events. We have a couple of conferences, IgluConf and PolarConf, that we host in Helsinki area yearly. And then we also have this one-day hackathon type of bootcamp events as well. And all of these are announced at our meetup page. So if you're not there yet, or if you haven't followed that yet before these, then please definitely join us there, and we'll have a lot of stuff happening there as well. And if you or somebody who you know has something excellent to share, even if they don't know about it, then please tell us as well, and we'll pursue them to actually come forth and have some talks as well. We don't always have to have a car full of people coming from Helsinki to do sets as well. All right, so today's agenda, as you've already seen, I'm going to start with some welcome words, and then I'm going to continue with these welcome words as well, and then I'll move over with my other hat to the presenter number 1, being myself, and I'll actually introduce a little bit more myself in that context there as well. And then we'll move over to Annie's session about managing Kubernetes application complexity using Helm. Very interesting topic. And then I believe we have some food, which is always good. So we'll break at latest when we have the food available. Let's see how we go. And then once we have grabbed the food, we'll continue first with Anti's session, and then we'll continue with Teemu's session for the last. And I believe Teemu's train leaves at 8 o'clock, so at least he has to leave by that, but I don't know if we have any other commitments in here, so of course we can do some networking here as well. And among these welcome stuff, I'd like to also talk about PolarConf, which is a new entrant to the scene of our two conferences. PolarConf is a IT Pro, so Microsoft terminology may be not really familiar to all, so Microsoft is still using this kind of old developers and sysadmins type of differentiation between their content of conferences. So this is PolarConf is about those IT pros, so sysadmins, people who don't produce necessarily code in their daily lives, but talk more about administrating identity management. We talk more about Azure automation. We talk about hybrid scenarios using Azure Stack, for example, etc. And this is going to be happening in October in Helsinki in Hotel Camp. So at least some here that we have had some salad type of experiences before, so this time hopefully a little bit something, or that time hopefully something a little bit more hardy for all of us. And this is just after Microsoft Ignite, so actually I believe 3 or even 4 people from our speaker set are actually even Ignite speakers as well, so it's also a good recap if you can't make it there, or if you can't make to all of those sessions at Ignite as well. There's some highlights from Ignite. I believe there's like Alex, Alexander and Rick who are speaking at Microsoft Ignite as well. And there's a very good set of speakers, all international ones, all either Azure MVPs or then representing their respective products. For example, Matty Stratton here talking about PagerDuty, he's an evangelist there, and also we have Mike Martin from Microsoft as well. Other events from Finland Azure User Group, we will also have our, don't get confused with the numbering, there will be after FAUG Tampere number 3, there will be the FAUG number 10 in the Helsinki area as well. And I believe it's actually like number 33 of our events ever, so we have different sets of numbering system as any other proper community stuff. So there's Ignite, there's PolarConf in October, there's IgluConf, which is focused for both developers and IT pros, so a kind of let's say premier event for our 2 events, because that's the one that we've actually held before. That's in January, and then of course Microsoft Tech Days is back again this year as well, after previously being gone for 5 years. So Microsoft Tech Days is coming in March, and we'll hear soon about those as well. If you're not there yet, get your Slack. If you're not there yet, get your Slack invitation at bit.ly/msgurut. Don't worry, there's also English-speaking stuff there. Listen to our podcast, Ikkuna Studio by Sakari and Jouni, who are not here yet this time, and then cloudgossip.net, where all of the hosts are actually in here, in this room. And then follow us on Twitter. I think we have a Facebook page. All of our YouTube recordings are also, if not recorded by us, then also at least Crows posted there. So these slides will be available through our YouTube by linking to your respective, I believe, Eficode's YouTube channel in there. All right. With that, let me switch gears a little bit and move over to introductory or welcome Carl to speaker number 1, Carl. And there we go. All right, so welcome everybody from my side as well. And this topic is going to be about security, a topic very near and dear to my heart. I have these ramblings of my own type of session about war stories, or this kind of top insert random number here, security fails in Azure, and how to avoid them. And there is a lot of stuff that we can cover there. You're also very free to comment and ask questions. Meanwhile, even maybe challenge me if you're there during these sets as well. But first, a couple of things about myself. As I mentioned, my name is Carl. I'm a Microsoft Azure MVP. We have 50% of Finnish MVPs represented in this room, which is great. I co-organize Finland Azure User Group, IGLUconf, PolarConf, Serverless.conf. I'm a podcast host at Cloud Gossip, and I've been working with Azure since 2011, and now 2 last years at Composer. And my day job is talking about Azure, so why not do it during the nights as well? And I tweet a lot as well. So during this session, I have 3 different topics that I'd like to cover. A couple of updates. I heard a couple of questions up front and comments about also providing some, let's say, newcomer-friendly questions and newcomer-friendly topics as well. So I will do a couple of these fundamental, I don't want to say introductory, but fundamental Azure concepts, an introducing those and showing those in practice. And I will show a couple of updates that have happened since we broke before summer. And then I have the list of random ramblings that goes on until Annie takes my place. So the top security fails and how to avoid them. It's an ever ongoing list. So very briefly, if you are familiar with Azure Security Center, this is something that came as a new update just during the summer. I believe just after the mid, and this is how everything looks now, and you don't have to bother about anything that happened there before. This actually makes pretty good sense. So actually what we have here is we have a nice dashboard with graphs and colors and everything. There's some talk about this better. So there's some talk about policies. I'm going to cover those. We'll see how well governed our Azure subscriptions are. I see that there's in this picture there's 28% of my subscriptions are in compliant of my rules, so maybe we could improve that. And there's even a graph that policy compliance over time I actually gone down. So my users in my subscription are not actually playing by those rules that I have set to them. Maybe should I be more stricter with them? Should I add some technical limitations? Or maybe is there something that I can maybe talk with them and guide them towards better enlightenment? And also I see that this security center covers 3 different subscriptions, and there's some talk about licensing, free, not, and all together with those 3 subscriptions, I have 50 different Azure resources, so different Azure services that I cover. There's some security VM host level security recommendations that I have in here. So there's amount of high severity incidents on high severity errors, quite a lot. All of my compute and app resources are in red, as well as my networking side. And there's some even more details here. You might not see this, but it's about 27% applied disk encryption has not been done. So, I should maybe have a look at this thing. And then there's this machine learning or AI side where we have these security alerts that are getting generated, and these are not really, I'd say, very intelligent. All of them are medium. They are attacking 2 resources, and as you see all the time, and they are actually about open ports, open RDP ports in publicly available VMs. So pretty standard stuff, but this is something that I actually get more or less out of the box in all different Azure subscriptions that are out there. So if you're tried Security Center before and kind of gotten terrified by how bad was it, this is a little bit better view on those things that happen in Azure. And if you haven't, there's a little box on the left down corner by default on your Azure portal that says Security Center. It's already there. You can do some engagements to get actually more data here, but by default you already have a lot of information about your security posture in Azure. So pretty neat stuff, and do check it out. All right.
I have a question.
Yes.
About these recommendations.
Yes.
Are those links which somehow semi-automatically fix your problems, or do you have to?
Yes, I think there's like some companies who deal with this. So no, there is links about automatically fixing your. So the question was about automatically fixing those recommendations. Security Center doesn't do that. I will show you today, and if I don't do remind me, a tool, another security-related tool called Secure DevOps Kit for Azure that actually does provide those scripts or at least guidance how to fix those. By default, if you talk about, for example, this host-level security, it's like VM patching stuff. There's like CCV numbers already available. It's something that, you know, those folks whose day job is to harden VMs and stuff like that, they already know those. So that's pretty common. For some of them, I believe there's like one or two things, like turning on the disk encryption and some other parts. You can also turn them on from here, but they're more the things that you would already you already can fix them by ticking a box in Azure anyway, so they're not very hard things anyway. But some of the things that you can do here. Excellent question. And do remind me of the AZURE. All right, so with that in mind, let's talk about Azure Access Control. And I will show this anyway. So this is a huge picture about everything Azure Resource Manager, but let's maybe kill the mic for a while as well. No, let's see how it goes. Typically what we were connected to, for example, customers. Those can be anything. Those are the actual Azure services that we use. But how do we grant those access? This role-based access can also be known in actual theoretical literature as rule-based access control. The idea is that I should not grant individual types of permissions to any user. They should always have a friend or a kind of template or a role that they attune to. So instead of granting two sysadmins separate rules, I should create a role or a template called sysadmin and apply that set of rules to everybody. Makes sense. And in Azure's case, we have those roles. There's, I believe, 70 different roles that are available. The main ones that we are interested in are the contributor, owner, and reader role. I'm going to talk about this in a little while. And those rules can then be, those sets of permissions or roles can then be set on in different levels. In Azure, the highest level that we typically see is the subscription level. If I have access to subscription, the access is inherited to everything underneath that. So all resource groups and all resources underneath. If I only have access to this particular resource group, then I only have access to everything in here. I don't see any other resource groups available. And as I mentioned, the
scope or the who gets the access is always in Azure AD. It can be an Azure AD user, it can be an Azure AD group, or it can be a machine or system account, or in Azure AD terminology, a service principal. So if you automate, of course, it's not a person, so you need to give some automation types of account to those. But what type of accounts to give? This is quite a common misconception, and this is more or less I could rant only about this part on my top security fails as well. So the owner role, these are the official definitions. The owner role can perform everything for a resource and its child resources, so the inheritance, including access management and granting access to others. So they can incur any cost, they can create or delete anything, and they can even invite their Chinese friends using bogus emails not from our company. We can't limit that only our company Azure AD is used in this scope. It's any Azure AD, so it can be anybody. And of course they can go ahead and delete all types of logs as well. So we don't particularly want to give that access to anybody. Then we have this one, the contributor, which is the default administrator role that should be used, even though the name is contributor, not doer or administrator. Can perform all management operations, including create and delete resources. Cannot grant access to other, but there's no other limitations that I'm not doing any access management stuff, but otherwise I can do everything. So this should be the default role. And then there's the reader that can read everything in that scope as well. But we can actually switch between these different types of roles. The role assignment, what access do I have, doesn't have to be static. So there's a tool in Azure AD if you buy some fancy licenses, you get this Azure AD Privileged Identity Management, which is part of some specific Azure AD. Ask your licensing folks in your team, or ask a quote from Microsoft. The bad thing is that you cannot add it for admins only. This is for everybody in your Azure AD. So in large organizations, everybody who has an email address or anything. So what it does is it enables on-demand, just-in-time privilege escalation, and essentially I can be by default a reader. When I need, I use the PIM to actually get my access to a better contributor or an owner scope when I need it. And it also generates nice reports about who does what in my Azure. And yes, so let's check out this PIM really quickly. So essentially I have two Azure environments available. On the left I have my pure and default colored Azure, and here I have my evil dark Azure user. On the same subscription, we both talk about this same, we are both trying to access this Azure subscription called Azure Meetups, but I'm just using a little bit different users in here. So on my dark side, you can see that if I go to the overview of access control in this subscription, I only see that some other Carl is the owner here. But if I go to the other Carl, who's the owner of this subscription, I actually see that there is 5 different role assignments available in here. And to demonstrate this a little bit more, if I go to my resource groups in here, I see that I only have 1 resource group, but actually inside the same subscription using a different user, of course, obviously I have 16. So how can I escalate my privileged identity? As I mentioned, there's a tool called PIM for this. I have eligible roles that can be activated. Let's click on that, that sounds good. Reader in the whole subscription. So that sounds good. Let me activate this one. I need to give a reason, no reason, and that's it. there's no, in this scope, there's no approval stuff added here. I could add approvers. I could add this to a group, user, anybody. And what did it say? Yes, your request is queued for activation. That's very useful information. And actually, I just don't get that information when it is activated. So I can just go ahead and try if I actually have that information or that access already available. No. Let's do a refresh of the page and let's see what happens. No user assignments. Perfect. So now I have all of these, more than one. So all of these permissions that I can see here. I can see the same stuff as the good guy Carl saw previously. And if I go to the resource groups, I only saw the one. Now I have all of the 16 available. And of course, reader is not really an administrator or privileged user yet, depending on the case. But you can imagine that how this works for all different types of users.
Do you need to explicitly set for every single user what kind of like escalated privileges?
I can do it based on the scope and a role. So I actually set this up from the subscription level. As a reader, these are the users that can request access to this one. Or I can set this group is the one, no matter what changes are made to the group. If I have an internal process that I need to maybe call someone or ask somebody who maybe even speaks with a funky accent or anything, once I actually get my access to that group, that's it. The AD actually syncs that up into my Azure AD. It doesn't. My Azure administrator doesn't need to do anything.
And time-based thing like the possible.
Yes. So by default, this one actually had that I had this was permanently available for me to ask, but it's always I can define based on how many hours is this activated at the time. For me, actually, I don't know if you noticed, but I actually had a slider from 1 to 8 hours. How much is it active? After that, I need to ask it again.
And like when it will get into effect, do you have any control? Is there any guarantees that within a minute or like 1 hour you will get the?
I haven't read the small print, but it's within 5 minutes. It's automatic. It's just the UI that's a little bit laggy there. All right. So in order not to spoil everything, let's have the last 6 minutes for the fastest rant possible. Top Azure security fails that I see, and this is really a caveat that this is not something that I came up. This is something that I, as somebody who only talks about Azure and only works with Azure customers and has the security hat on from time to time as well. This is the reality of what I see in Finnish and multinational enterprise customers. So let's start with this. Everybody is typically the owner and in the subscription scope, so it inherits down. This used to be the reality. This was the only option in the old Azure or one generation previous access control model, but it's already been 5 years, so you should maybe update your practices. And it's just not good practice that everybody has the possibility to kick out everybody else and invite anybody into that same scope. And of course, keeping in mind that everything that we do in Azure, we can incur any types of costs. So this can be, the largest Bitcoin heist as well. Another one is that when we are using these system accounts or service principals in Azure buzzwords, they have 2 wide privileges. So again, everybody is an owner and everybody is assigned in the subscription scope. Very typical: access control, privilege escalation, access control creep. The other one is that we don't monitor anything. We don't have audit logs. We don't keep any tabs on what's happening in our Azure in terms of user management or who actually did what particular action in Azure. Remember, everything that goes through the Azure Resource Manager, we are always authenticated. There's always a log if we keep that in mind. By default, the logs are retained for 1 month only. so you should maybe do something about it. It's like almost 3 clicks that you have to do, and there's almost, of course, you have to pay for the storage for the logs, but keep those logs, please. Of course. No alerting. So it's good that we fixed our monitoring, but what happens when something goes wrong with either us or maybe our application or even Azure? So we don't know. There's Azure Health that can give us access to information that, hey, maybe Microsoft broke something in our Azure system. Maybe there's a system-wide service disruption that's going on. That information is all there, and I can go to any of your Azure subscriptions if I have the access and see all of the history that's related to that. But by default, if you don't go to that specific page or in your Azure portal, you just don't know about it. You might think that it's your application's fault, or at worst, you don't even notice that you have downtime before the customers call you that what's up. And when they do, it's good to know if Microsoft has already provided you with a nice PDF that they actually do, that this is their fault. It's a lot better than saying, it's the cloud, it's raining, so it doesn't work always. Alert and monitor with your Azure Security Center, of course, your databases, and if you have enabled your web application firewall, of course, with that as well. The other one is storage account. So the reader, what I mentioned, is not enough for reading storage account data. So Microsoft binary large objects, or if you're using some other clouds, they might be called something else, but essentially a place where you store most of your Azure or cloud native stuff, your VM disks, everything. Those are used in Azure not with this role-based access control, but with the crappiest key pair possible. So there's one master key and a secondary key that's available, but both of these work the same way. There's no log who used this. The same key is available for everybody who has access to that storage account. And with that, you can create, delete, read everything in that storage account. So we don't really want to use that as our we don't want to store that anywhere. We don't want to put that in any key vault even, but we would like to have somebody else to manage that. And Azure Key Vault, and with some automation, we can actually add some key rotation for that, so that the keys actually change all the time. And instead of asking in our application or giving our developers access to the actual keys that are the kind of master keys for our storage forever, instead of that, we can just tell them that please check the current key from that key vault, and you're done. Very useful, has been around for quite some time already, so please do get familiar with that functionality. Again, very typical, everything in Azure is public. There's a nice Excel file that you can download with all possible Azure IP addresses. All public Azure IP endpoints get spammed, and there's DDoS attempts that even reach your side. And if you create anything in Azure, like such as a VM, you will get login attempts all the time. So please protect those. And with the logs, if you don't monitor anything, it's okay, but if you monitor, then please check those retention times. The UI is very bad for setting that retention time at the moment, which means that there isn't any, but it's still very much possible, and you should do that. And of course, as with any VMs, if you had to deal with VMs, please work with them as they were your own VMs. Patch them, secure them, etc. Preferably kill them as well. All right, this is my last slide and my last minute. So some more resources for all technical definitions of, for auditors, how does Microsoft shred all of their hard drives when they are not in use, that kind of stuff. Check Azure Security Center, Trust Center. That's just a web page with collection of all of those details. For using the Azure Security Center, which is the security monitoring tool that I showed in the beginning, there's a free Pluralsight video course available. If you want to build your Azure virtual network as you would build and secure your on-premises virtual network, there's a nice set of references and discussion about that in an ebook, Azure Virtual Data Center. And if you really need to build some PCI DSS compliant web environments using Azure Platform Service Technologies, do check out the blueprint section of the Azure Trust Center as well. With that, thank you. Questions? 5-second rule, so thank you everybody, and Annie, it's your show.
Well. So I'll be speaking about managing complexity in Kubernetes with Helm. How many of you have heard about Helm? Okay, a few, great. That's good to hear. Then you might be wondering now in the beginning, who am I? Who is this random person talking to here? So I've worked quite a long time in the tech and startup community in Finland. I am one of the Kubernetes and CNCF meetup co-organizers in Finland. And I am also involved and the producer of IgluConf and PolarConf, which are the biggest Azure only events in the Nordics, as Carl mentioned before already. And I am as well co-host of the Cloud Gossip podcast. And it might be a bit too non-technical for this room, but if you have any non-technical friends who would like to learn more, that's always a good, I think, place to start. We have a really good recaps of things there. And I've worked as a marketing professional mostly, or a startup coach or something along those lines in companies like UpCloud, Microsoft, or HiQ or whatnot. So I am not saying that I'm an expert on these matters at all. I'm more of a maybe non-technical person by start, but I want to learn and I want to learn more, and I like sharing what I've learned. So this is more of a what I learned in recent times kind of talk. So to the topic then. So Helm, it's the package manager for Kubernetes. So Helm is essentially the best way to find, share, and use software built for Kubernetes, as you can see from the fancy image by Helm. So what is it actually? So it's maintained by CNCF in collaboration with Microsoft, Google, Bitnami, and the Helm contributor community. So it started as a Kubernetes project, but then it became some interesting and its standalone worth. So it became actually a CNCF project in the incubating stage. So if you're wondering what is the incubating stage, it's kind of like the middle tier. So there are 3 different tiers in the CNCF Foundation. And actually the incubating stage is the most crowded one. So there are only 2 projects that have graduated. So it's Kubernetes and Prometheus. So it's the one with the most projects. So it's still very legit and it's in a good crowd in general. And then we have that specific for Helm 2, so which is the current version. So it has 2 parts. It has the client, the Helm, and the server, which is the tiller. And the tiller runs inside your Kubernetes cluster and manages releases, aka installations of your charts. So Helm in Helm 3, unfortunately, as life is not always fair, everything will change. Not quite everything, but you know it's gonna go to a client-only architecture. So it's always fun to get these upside changes. Yeah. So what are these charts that I was talking about a bit? So you can think of it like a Kubernetes equivalent of Homebrew Formula, an aptitude package, or a yum RMP file. So they are essentially Helm packages that contain at least 2 things: a description of the package on one or more templates which contain the Kubernetes manifest files then. And charts can be stored on disk or fetched from remote chart repositories. So why is Helm usually quite good? So it's really good at managing complexity. It's really easy to update. It has very good sharing, and it's easy to roll back to the older version. So really, in a nutshell, Helm's job is to make your life a lot easier. For example, who here likes writing Docker files? Anyone? Okay, a few people. That's okay as well. But you know, you can always just let the machines do it. It's quite nice. So, time for a demo, which is easily deploying a complex application, in this case WordPress, to Kubernetes using a Helm chart. So, if I move this a bit, then we can get to the terminal. Into a tiny, tiny terminal there. Let's make it. Okay, well, that fucked it up even more. Let's try to get it so that everyone can see at least something. There we go. I guess it's somewhat visible. Yeah, I see some nodding. That's good. That's a good start. So if we do Azure account show, then we can see that yes, I am logged in Azure and it's working there. And then if we do kubectl get services, we see that yes, there is Kubernetes happening, but there isn't any kind of services yet. And then, just to prove extra, there isn't any Helm lists or releases either. So if we do Helm search WordPress, yes, you can see that there is a WordPress chart version available there, which is very nice because we're going to be using that. So it's quite good that it's there. Helm install stable WordPress. I'm really bad at typing, so I have to actually check every time that it's correct. And then let's wait. Yes, we have exciting zebra happening, which is quite exciting as the zebra is as well. So in here, if we go to the services, we can see that there are things that are happening, but we do not have an external IP yet, which is the goal of this demo. So we're gonna have to wait a bit for that. It's gone from anything between 2 minutes to 6 minutes, but don't worry, I have actually programmed for that time as well, so we don't have to just stand here, hopefully, if it doesn't take 15 minutes. So that's good. In the meantime, I can, for example, in here, there's a really neat thing. So you have actually, you can get the password super easily.
Could you zoom it a little bit more, because in the stream they don't see it.
Okay. Better?
Yeah, I think so.
Okay, good. Let's see. And then if we do that, yes, we see now the password there. Everyone can see it now. Very neat. Very nice. And then we can check if it has come yet, but I doubt it. Yeah, but then in the meantime, while we wait for that to happen, we can actually go to learn a bit more about Helm, about installing it, which is always fun. So now that you're very excited to install it, you can now learn how to do it. So for package manager, you can either use Homebrew, Snap, Chocolatey, or if you want to do a manual install, you can use downloading the binaries from GitHub or whatnot. And then, so after you're done with that, you are gonna run Helm init to initialize Helm client and tiller to your running Kubernetes cluster. It will also set up any necessary local configurations then. And do note that if you need to have a running Kubernetes cluster and kubectl setup. So depending on your setup, permission changes for your Kubernetes installation might be needed there. And then when it looks like this, where the red arrow points, it's gonna be success time and everyone can pat themselves on the back and be happy. And here are the few Helm commands, which few of them I already used. So you can use Helm search to search for charts, or you can use Helm fetch to download a chart to your local directory to view, Helm install to upload a chart to Kubernetes, and Helm list to see list the releases of charts. Yeah, and then I think it's still time to wait for that one. So
if you need to do any kind of scaling of your services, you just use Kubernetes. You don't deal with the Helm. Helm is just for deploying and installing, like kind of making it available and easy installation to your cubes like Kubernetes.
yeah, you do. If I can show if you want to scale, you can do it from Azure portal as well.
Yeah. So
Yeah. So actually, that was kind of like the next thing that I was gonna do, very nicely. So in here, yeah. So in here, you can actually, if you go to properties maybe first. So here you can see the node count, the total cores, and the total memory, and the fact that location is West Europe in Azure at the moment. And then in here, as asked, you can see the scaling, and if you want, you can just, let's do maybe 3, and then you just save and it's done. Very nice and simple. Yeah, and then I can show you another thing inside here. So if you go here, you can actually see that the virtual machine is there, and the new one should be popping up as well eventually there. Yeah. And then we can actually pop here again, just for extra confusion of switching places. Let's see if it's there yet. It is. Well, actually, the external, it is there. So, yeah. We can try it, but I doubt it might not be actually up and running yet. But we do have other things that we can look in the meantime. Yep, not yet. But then we can actually check. These are longer commands, so let's do Kubis control cat bots. So in here we see that actually it has restarted twice already, hence why I think it might be taking a bit longer time, which is nice. And then we can do Helm inspect stable /WordPress, and then we're gonna see a lot of different things, like a lot of different things. And this is quite nice to kind of highlight also what are all the things that you would have to, get done to do this if you were to do this manually and with Helm. So it's quite neat. Let's see if it's working now. As always, no, not yet, but as always in demo, it's gonna take way longer than ever when you're trying it out yourself. So let's see if it's happening yet. But there is actually one more thing that I have in my list of things to show. Now it's working. Of course, the magic when you're about to move on to something else. It's up and running, very nice. And then I can actually even do this and sign in if I see the password. I just saw it here. If anyone spots. Yes, like this happened last time. I was doing this a bit down or. Export. Yeah.
Lower.
Lower.
A bit more. A bit more.
Over.
Yeah, but I could actually.
Oh, there.
Yeah, perfect. Thank you. I'm like blind anytime I try to find it. So then we go here. We do this. Login. And yes, we can actually start modifying the WordPress now even. Yeah. But that's it for my live demo and the presentation as well. I can get the thank you slide up running. Thank you.
Any questions?
I have one. I mean, you mentioned about like who likes to write a Docker file, but I think this is not really replacing the Docker file. You still need that one. I think this is more like replacing your Docker Compose, because this kind of, or Docker Compose, or like the service installation of many services, whatever you have, you still need to have Docker images and Docker
Yeah.
files for those. So it's not really
It doesn't do everything,
Yeah,
unfortunately.
it's more like who likes to write Docker Compose
Yeah,
or
yeah, yeah.
something like that.
I have one question. So there are community created services there, or so how trustworthy they are. So
Well, it's still on the integrating phase, and it's quite new. It actually went to the underneath the CNC Foundation only this year, so it is new. But I think it's still quite trustworthy. There's a lot of contributors, and it wouldn't be part of CNC Act if it wasn't.
It's like Google and function top there, so either you trust them with your Kubernetes tooling or you don't use Kubernetes, I guess.
I'm getting more legit every day as well, if it's not yet. Any more? No.
Okay, thank you. I think that we have now something to eat and maybe have some social time as well.
15 past.
Yeah, so let's continue with 10 past so we can keep the schedules as such. Thank you.
pitää tosissaan mennä 4 kuntia, jos mä haluan. Saat sä tällä? Noin. Okay. I'm going to talk with AZURE Data Lake Management. How many of you know what is the AZURE Data Lake? Quite many. Okay. Oh. Okay, this is a short introduction. I'm working with Eficode as software architect. Working with software about 21 years and had coded from 35 years or something like that. Been in a software architect at about 9 and working with AZURE Data Lake about 1.5 years. So in the very beginning. It came last year. Please ask questions and disagree with me. Okay, what is the AZURE Data Lake? In this solution, because it's so abstract term, I said that it's big data solution. The next question is, of course, what is the big data solution? Big data solution is something that you put several data warehouses in. So you cannot use it in data warehouse, then you have a big data solution. And you must import the data. You can use AZURE Data Factory. It's quite nice, but it has limitations, and especially if you have to do conversions in the import process, it's not suitable for everyone. You can use Spark, which is, I think, the main way that people put data to AZURE Data Lake, because it provides easy way to transfer the data in the import phase, and you can connect it with the different data sources. And there is, of course, ADLS, AZURE Data Lake Storage SDK, that if you have some special reason, you can directly write to there. To processing data, you basically need Spark. There is basically no alternative to that. Data is stored ORG or Parquet format. They are columnar formats both, and I will shortly show what the little difference they have. But the point is that you need to convert your CSV to either of them to have some performance.
Can I disagree at this stage?
Yes, you can, but if you look at the specifications, then the CSV.
No, not this one. It was the previous one that post-processing is happening with Spark. I guess at least if you look into like the
pre-processing.
Huh?
Pre-processing.
Wasn't it like post-processing?
No, then it was my typo.
Okay, sure.
Okay, I mean this is from Microsoft. They have used here the Data Factory, and if you look at, there's the storage, and this is for the analytics. But basically, you can move it there. Then you have the Scala programs from the Spark do little bit manipulating to get it something that like SQL data warehouse, analysis services, and things like that can use. Especially if you have a lot of different data sources, you have to some way to get some common things for them. Okay. The first text was they said was it fetching. I used the term importing. That you have to get, if you have big data solution, you have to get a lot of data, and you have to import it. Basically, you provide configuration information from the data factory or the Spark process to tell that where is the data that you want to load and what of the data you will load. Then, when you have selected what to load, then you can strip it, something like remove the social security numbers and names or some private information. Or if you have some weird XML format like edit, you may have to use the AZURE Data Lake Storage API to read some edit message and just pick the real data from the edit message and write it to the storage. In real life, the managing is managing the applications that import the data. That is the totally normal administration of the service. It is not anything data lake specific. You must have alerts for full disks for the services that are running, that you look at that everything is running. That is nothing that that was I didn't say very much for that. Especially when you are talking with the incremental import. So when you take the first batch job, took the 10 years of accounting and put it there. Okay, that's one time job, and you'd probably have to never do it again. That at least that should be that. But if you want to do near real-time analytics, you need get the current data too, and that's when the things get a little bit tricky. The biggest problem is the keeping number of files below 5,000. Because the code will show it, but that is you can do it by using Spark for repetition option, and there is a couple of sizes. If you are using org file format, the best size is 6 megabytes, and if you are using packet, then it can be a little bit bigger. Okay, this little Scala code does the repartition for the some directory. This is the whole business end. So it's not very much of code, but what it does quite a lot. Okay. When you're writing Scala programs, you normally don't get variables in the between, so it's written in one string. Okay, the Spark read org stack. It reads the data frame, but data frame is not the data. It's information about what is in the directory. And you don't access files, you access directories. And this is one thing, that if you have a lot of files in the directory, this takes 15 minutes, maybe half an hour, or maybe never you get it running, because this, the stack goes over. But the size of the files doesn't matter, because it doesn't read the files, just the information about the files. So even there is terabytes of data, it works fine. But if there are 10,001 kilobytes of files, it doesn't work. the number of files is critical. So we first get the data frame. Then what we were now doing, we are report partitioning. This is variable. As the last slide, I showed that depending on the size of the format, there is the optimal size. So you calculate what number of bytes there is to the directory and split it so you get the optimal count, and it generates that many files. For example, if you have this 1 kilobyte with 100,000 files, you would get 1 file after repartition because it is smaller than 275 megabytes still. And after that, searches in that directory would be blindly fast. But one thing to remember, this is not something that you cannot, if you have incremental data, you must do these operations. Of course, you must automate them somehow. But this is not the system that you can just, there is no GUI tools for this. There is no server options to turn on and off. You have to write codes to keep it, the Azure data lake storage, healthy. It stays healthy in technical sense, very reliable, but you cannot read the data. Basically, I say that then it's corrupted. And if you think a little bit about, as I said, that 10,000 is way too much. If you have like 1 new file generated in every minute, it doesn't take very long to get 10,000 files. So this is constant operation. And that makes that more important than any other data management platform in Azure do. Keep coding. You need, there is no maintenance tools that you can use. And one other thing, let's see the next. You may know, you probably didn't know this, but here. You shouldn't save it to the name directory. And if you don't tell it, if I put that there the same directory, it would tell me that that directory exists and through exception and quit the program. Because you cannot update the data. You always generate new data. The old data is not touched. This is one huge difference to the data warehouse or many other, or any database normal usage, that you constantly update the data. You can only add data.
So I guess storage requirements are very, very high with this system.
This is the Azure Data Lake Storage is a service that let's say that their space doesn't cost almost nothing, and you don't have to care about it. The name comes from Azure Data Lake Storage. That is the system that you store the data, and Microsoft up keeps it running. It's like one huge network drive, but yeah, there's stuff. You have to remember also, this is the folder can't exist. Even if it's empty, it will fail. I think that is very good reason. We don't want to mess with other people's, because we cannot alter the data. We want to get something done for ourselves. We put it in a different place. And that is important. Azure Data Lake Storage doesn't have almost nothing secures what you do. You can write totally different kinds of files in the same directory if you use append, but you cannot read them there. It only tells you that there are different kind of directory files in that directory. I quit. And you cannot put these kind of checks there. That's why, if you want to make something, you have to. That's why it's good idea to put every change in the different directory, because if you put them in the same place, in some phase you won't make little typo and type two different kind of files in the same place, and let's say that finding those two different files in the same directory isn't fun, and it takes quite a lot of time. This is something that also, if you are working with relatives and databases, you may find a little bit like shocking, maybe even. There is no real way to say that the writing is done. It will generate last the success file, but it's 0-bit length file, and anybody can delete it.
I guess it's good to mention here that this is specifically for Spark writing,
Yeah.
because you can write a file
Yeah.
to the browser yourself, then you don't get any success
Anything.
or anything. Yeah. So this is Spark specific.
Yeah, and that's not very good either. Probably everybody who has worked with the databases has had a situation that we have to add a new field in the database. Like that nationality or for people, and mobile phone number or something like that. Basic things. You have to add a field. But in Azure Data Lake, that is more easily said than done. Because, as I said, everything is immutable. So you cannot modify the data. So, what we have to do? Oops.
We do nothing.
Yeah. This is small example. Again, Scala. We have our current data. We have to add a new column. And that is one also thing that there is no way to, if there is just column named that already, this will be put null there. So if you run this again and forgot that you run it and you have put some data to that field, you will lose everything. If you put them, if you use the same directory. Because normally you have to start these manually, and you want to start them manually to check that there's enough resources in cluster, that you inform the users that this be hugely updated now, that if you do queries now it's going to be slow and things like that. And because you start them manually, you make mistakes. And if this would have here save there's a file option delete or replace, I don't remember, outside, it would flush all the data. And because all the commands is like this is doesn't provide any checks that if there is such a column and you have to change its type, you have to do it this way too. Of course, you probably want to read the value there. But I think that you have now probably figuring out that the changes in the data lake are not trivial. Especially if you think about this way. In our environment, we have to make change because the source system changed the database. But there's quite a amount of data in that table. It took 18 hours to run this change. So you don't want to run it again. And here comes some neat features also. You don't want to copy anything at the AZURE data lake. When you have written the new directory, what you want to do is go to the old directory and rename it. We have used like underscore and the date that it was modified, and then rename that directory that you create to replace the old one. Because that operation will take about 2 seconds, because it only updates the metadata. But if you want to copy them, come on next morning. And the copying API is also quite not very reliable. So it just says that something went wrong in the copy phase, and please try again. Okay. This is not awful, but it's different from any other data platform that I have used. If you like coding, especially if you like functional coding, you will love it. Because the data sizes that you can analyze and through things are so huge, and the programs like this, you can do a lot of things. The programs are not long normally, but very use a lot of functional techniques that you get data frame and you somehow change it, you get other data frame, and so on. One not so nice thing for this, there is no way to debug these. Because when this job is started, it's submitted to the server, the Spark cluster disperses it to the nodes, and the nodes act independently. Getting even the logs for all the events may be challenging, because the machines that did the processing has already gone. Especially sometime last autumn, there was some problems with the Hode inside clusters that they need to leave that if some calculation node went down, it deleted its own logs. And because the logs is the only way to debug it, it was quite annoying. But how if you want to remove something? That is basically impossible. You have to, if your current system, the source system, doesn't anymore provide that information, if you don't want to lose all the data in that field, then you have to put move there. And that is one thing that requires you to make sometimes quite complicated integrations to get it running. As you notice, this is typed. And one thing is also that if you try to save it with the wrong type, it's just. Yeah. And let me try to you a little bit more. This nice feature. As I said, the lot of files is a problem, and this system generates new files in every run. So let's say that maybe you can do one or two changes before your data says is going to, but you have to do the repression. But because it's quite slow, you don't want to do it more often than it's needed. The reason is I typed it there, but it's quite easy to understand. When I have 10 files and I have 10 nodes, everybody gets one. But if they get their own ready, they can take a part of the other, and then it splits it two. Basically, normally it's instead you have because normally you have way less nodes than you have files. You maybe normally multiply the original file number by the number of the nodes.
You mean divide?
Multiply. If I had 500 files, if I have 5 nodes, I probably have 2,500 files after that. And as I showed the picture, let's see if I. Here, please. Here. manage that? If you have different kind, like this, they use log unstructured and business structures. If you would like to see how many sales your web store makes when they are using some web server, a web service, you probably will get the information that somebody is accessing that from the logs, and information that something was sold from the app system. And you probably want to run them like a Power BI. Would they give us nice graphics for that? But if I try to put those things in Power BI, I will get nothing. So here I take my trusty laptop and go to code editor and read here what I need here, and then convert this to the new data. I decide new table that it contains this and the necessary information from that, and generate the new dataset and write it there. Because Spark allows you to write the data also to the SQL server. Like if you have this data warehouse there, you can analyze it with the Power BI. You get the data in, then you have some business case, and you look at what I have and try to scrape up the data to there. Because in the AZURE data lake, if you don't know how to code, basically you cannot do any analysis. And let's say that I'm not specialist about how to predict customer consumption from the sales. And because nowadays these tools are quite easy to use, and there are a lot of people who can use them, so the people who are administrating the data lake will provide them the dataset, and they can do the analysis. So this is administration done by coding. Because nothing here, if you especially use AZURE Databricks, these are all services that are provided for you, and you don't basically need to administrate them. But if you don't have a qualified people do this, you basically have a lot of bytes in this storage which you can do nothing. And how do you find out this? Little asking. No, I'm going to the yeah. This is that I put it the last slide here. What it's different from data warehouse. The one thing is I think missing here, yeah, is that basically data lake is useful when you have multiple data warehouses that you want to combine. It's because the space is so cheap and the tooling is so low level that there is no limitations put by manufacturer of the data warehouse tool, because you just have files in the directory and the data file formats are public. You can get everything there. One annoying feature that is also why you want to have less files is the AZUREs, because they are updated by the file, not the directory or the directory structure, but the file. For example, if you add new user, you have to re-authorize, in certain cases, whole the directory structure. And if you have like 400,000 files, it will probably take about 2 hours. If you are lucky, it will go through. If you are not lucky, then it fails and it doesn't even tell you why. Basically, this means even keeping the database security correct, you need to have maintain the file structure. And I think that is where I want to end this. But I'm just one thing last. This is developing. There's now new version coming, which will be faster, but it will only have the Spark support. That picture was the new version. So please ask some questions. I have about 1 minute left, I think.
Maybe I can ask, like, I mean, like, I kind of know it, but it will be nice because the last slide was pretty depressive from perspective why you would use data lake, because there is only like negative things about it. So maybe you can say what's the positive stuff about data lake, why you should use it, in what cases.
If you have a lot of data sources that are not in the data warehouse yet, it may be easier just put the current data to the Azure data lake and manipulate it there. And one other thing is, of course, that you can put huge amount of data there and store it with very little money quite long. If you are ending using some system, but you want to keep the data, but you don't want to have like Oracle licenses that costs 100,000 euros. You can read that Oracle data to Azure Data Lake, and it's safe there if you need it 3 years ago.
Good enough.
Yeah. But it's not ordinary system, but it has, especially like that if you are not hurry. Let's say. Okay. Any other?
Next, we are going to have Teemu, who is taking us to hanging in the edge.
Sure.
There's plenty of pizza still left, so if you're hungry, go ahead. You are not still. Yeah.
One pizza.
It's pizza.
You don't eat fast food.
been Microsoft Azure MVP since 2014. So by some really random math, that makes the 5th year now. I'm also a Microsoft certified trainer. So I'm one of those guys who tries to go around Finland and make sure that companies know how to do Azure well. And I very much focus on software developer Azure training. I don't do IT pros, so if you want to hang servers and you like servers, I don't like them. I'm not a good guy on that. I work in a company called Cloud Paralysis, and then I organize lots of things. The only thing that I currently want to mention is the PolarConf in Helsinki, 2-day Azure conference. We have talked quite a lot about it already. But today, I'm going to more talk about Edge. So if we think about waves of innovation, which is always interesting, is that waves of innovation of what? What kind of innovation are we talking about? Well, we can start from the cloud. And this is very interesting that I don't even want to start from like what happened before the cloud, how did we get into the cloud? Let's start from this discussion that you're now in the cloud. What's next? Well, next we are taking the IoT. So to get more awareness, to get more data, to get more intelligence, we need data. And the best way to get data is not to ask people. If I ask you how much soap opera or reality TV you watch, you always say, well, maybe 1 hour a week, because that's what people answer. If you look at the real statistic, people watch 4 to 5 hours a day, average, which is insane. So people are lying. So the only way to get real data is from devices that are really measuring it. So what next? Then we come to the edge. And this is very funny that after we have spent huge amount of time and effort to move the computing from on-premise to the cloud, now we are moving it back. Why are we moving it back? There is lots of things that don't make sense to put on the cloud. Now we are taking it back. And one of the things is that what happens after this? Maybe not in this order, but normally what happens next is AI. And with AI, we are not talking normally anything more fancier than machine learning. But even with machine learning, you can do really, really interesting things. So why the edge? So when we moved Internet of Things to the cloud, few things were that we wanted. We wanted to remote monitoring. We wanted to know remotely, is that sensor working? Is that data pump working? Is that motor working? That kind of things. We wanted to know elevator status. That's nice. Now we can control it. Now we can monitor it. The next thing we wanted is merging the data from lots of different sources. Who here has any IoT stuff at home? How many of you have more devices from more than one brand? How well do they talk to each other? They don't. One of the things is that why do you want to gather it in the cloud? It's easier to merge the data in the cloud. Merging it, let's say, if you have like IoT Hub gateways or something, they don't talk to each other. You cannot merge the data there. If you move it to the cloud, then they're like, yeah, of course, we all export the same database. Just go and merge it. Easy. Another thing, almost infinite resources. If you want more storage, pay more money. If you want more computing, pay more money. If you want something else, there is the service. But then there are scenarios where we just cannot do it in the cloud. There's lots of different reasons. Here is a few of them. One of them is that we need to have very tight loop and very low latency to control something. Have anyone of you seen industrial robot? They're amazing. If you would say that this industrial robot is connected from the cloud all the time, I would run away. Because most of those robots, if you ask the guys who code them, they're saying like, yeah, 1 millisecond latency is pretty long. They're like, yeah, so if you're talking to the cloud and 1 millisecond is long, this is not going to go well. So they need something way, way more faster. Another thing is that if you tell them that, let's just say we have a car manufacturing in Sweden, Volvo. If you go to Volvo and say like, yeah, if the network goes down, your production line is going to be stopped. Do you think that they are going to accept your excuse like, oh, you know, somebody dropped the cable, we're going to be stopped for 2 months? well, that probably will never happen, because if you think world without internet for 2 months, I mean, we would be totally dying all out there. So having one production line not working is not the issue, but let's just say it's only going to affect them somehow. They are not going to be like, yay, that's good news. They're going to be, you're fired, next guy. So there is scenarios where offline is a must. You cannot be dependent on the online. Then of course, privacy of data. There is lots of factories that are super secret. If you, for example, go and ask Coca-Cola, what's in the Coca-Cola drink? They will tell you like, these are the things, but if you ask how do we make it, what's the exact process, that's top secret. They never want to have that in a cloud. Even though I don't know if AWS or Amazon or Microsoft or Google would be interested how to make Coca-Cola, but you know, you never know. So there is lots of those reasons that why you want to keep it exactly on your premises. The another thing is security requirements. Lots of these factories are very, very paranoid about security. They're going to say, to get into the internet, there is going to be this process where two people need to go and put the keys in there and turn them in the exact same moment. They need to look into each other's eyes and be within 5 milliseconds, and then we enable the internet for 30 seconds, or whatever process is. They have scenarios where they are very, very strict on that. There is not going to be internet. End of the discussion. Of course, they are going to change one day. If you look at Tesla, they are more modern factory, they are more, but at the same time, it's not going to be all the factories at once. They are, let's just say, if industry is slow moving, real factories are even more slow moving. So, Microsoft created something called AZURE IoT Edge. So after they made AZURE IoT Hub. The next thing is AZURE IoT Edge, which is meant for your on-premise installations. First of all, security. It's fundamentally important that whenever you think about industrial IoT or consumer IoT, security is important. These days, if you look at any of the news, most of the new hacking stories where somebody has hacked insane number of devices and is doing denial of service attacks, what are those devices? They are security cameras. They are random internet connected devices. Why are they getting hacked? Those devices don't have that much processing power. They normally have pretty weird setup. And those companies are like, oh, you know, we are not going to be attacked. Because why is somebody interested in that? Well, I might not be interested to know, is your dishwasher on or off? But what I'm interested is that if I can run my code there, I can use your dishwasher to attack the Nordea or any other bank. And you're like just contributing to my nice bot network, even though your dishwasher just tells you is it on or off. Another thing, most of those companies are not good software companies. They haven't ever written anything that's meant to be publicly exposed or something that's going to be attracting lots of hackers. They have never had this kind of like issues. If you currently go and buy a new dishwashing machine or clothes washing machine, they're all going to be IoT this, IoT that. I mean, they might be really nice someday. I mean, those features that they currently have, I couldn't care less. I'm just seeing them as security holes, but maybe one day they have nice features. And hopefully they take security very, very seriously. Then, cloud managed. Even though that you might not want the data to end up in the cloud, what you want to do is you want to manage them. Why do you want the cloud to manage your devices? If you need to do any kind of management yourself, that's the hardest way to get right. If you look at most of the hacks, how do they get them? Most of them are like, oh, so to enable debugging, you just need to send this one payload. And now you have the full admin rights to the device. Or the password is always same, or something like this. Building an IoT management layer is one of the hardest parts of building secure IoT device and communication. So that's why Mike is thinking, yeah, we will take care of it. So you don't need to do and screw it up. And I love it. I mean, seriously, that's super important. Another thing, cross-platform. So these days, if you look at the IoT devices, I would say less than 1% of them is running Windows. Probably way more less than 1%. But that is, of course, maybe changing one day from Microsoft's perspective. but they are aiming both for Windows and Linux systems, so they are supporting both of them. Another thing, portability. So making it as easy as possible to write software, create dev and test environments, create continuous integration, continuous delivery, making sure that it's very easy to do deployments. Because if even I have a very secure IoT device, if it's somehow really hard to make deployments the official way, what am I going to do? I'm going to make an official way to do something with that. And if that's the case, I will bypass all the security. And then of course, that's only for development, right? Then comes the support engineer and say like, oh, this is a very fancy way to do support. And then they're going to ship that to the production with that fancy way to do support. And then hacker is going to go inside of that. So lots of effort on that. And then making it extensible. Mike's just figured out that it's not their job to make the full product. They're going to give you the infrastructure, the baseline, and then expect everyone to build on top of that. And I think it's going pretty well. A little bit of like what kind of scenarios are we talking? So, reliability requirements, and then how much custom code do we require? If we're talking about straightforward business logic, turn lights off, turn lights on, gather information, filter data. Let's just say we're filtering the data that we are gathering the information, is the light on or off? As long as it's not flickering, so meaning going on and off very quickly, we don't really care. But as soon as it starts flicker, we want absolutely to get that data. So we can write a very easy filtering that says that only if something is happening within this time frame, we want to get notified, otherwise we don't need any of that data. So very straightforward filtering. Another one is batch data processing. So if you have millions of devices that are sending the data every second, that means million requests per second. If you batch them, that might mean 200 requests per second, because you can batch that many. So batching is also very important. Then if we go a little bit more advanced scenarios, we're getting into all kind of translation stuff. How many know Philips Hue? They're smart light bulbs. Really nice. What protocol do they talk? They are using something called Zigbee to talk to, from bulb to bulb. If you want to connect to a smart Hue, you would need to write some kind of translator that can talk to the Zigbee protocol. So you need something physical, and then you need some kind of protocol to transfer that to whichever protocol you want to really talk to. So these kind of translations, or maybe you have OPC UA. OPC UA is a very common standard that most of the industrial IoT devices are talking. So if you connect to any kind of advanced new machines in your electricity center or your hardware pumps or water pumps or anything, they're going to talk OPC UA. But you need to have a converter and translator to translate that. They're nice stuff. Then, good example is home automation hubs. So home automation hubs normally talk different languages, different protocols, and convey all of it together, and then talk to your nice iPhone or Android. Easier to do the conversion there. Then if we go to something really hard, then we can get more to autonomous driving, autonomous fleets, more like machine learning. If you, for example, install an elevator, knowing exactly that this elevator is going to break in 2 days, 2 weeks, 4 weeks. So you can do that kind of calculations on your edge itself. Interesting thing, what is the typical hardware requirements? When we're talking about the small, easy stuff, we might be talking something interactive tier. So we're talking something smaller than Raspberry Pi. If we're talking about autonomous driving, I can tell you Tesla doesn't have a Raspberry Pi. They have something a little bit more heavier to do the calculations on the car. So everything is depending a lot, is like, what exactly do you want to do? The more calculation you want to do, the more advanced calculations you want to do, the harder your edge will be. So personally, I'm currently building a very large IoT project for a customer. Our smallest edge that we support are smaller than Raspberry Pi, Our currently high-end is a rack server that costs you around 100,000 euros. So depending on how are you going to install, what are you going to do, it's somewhere between that line. And same with the AZURE IDH. The idea is to support very high-end stuff and support as low as possible. Then a little bit about security. Linux, Windows, and multiple platforms. So ARM, normal Intel processors. So everything of that is supported. All of the protocols are standardized. So Microsoft didn't come up with like, oh yeah, let's come up with another protocol because all of them suck. They are using MQTT and AMQP for most of the stuff. They're using the normal WebSockets to do the communications. Another thing, secure technology isolation for app developer. How many here has written app in a teams where there is more than one team contributing to the same app or same system? How many of you have had like no problems with the other teams doing strange stuff? Especially if you're running in one physical server. Because we are talking about running in one physical server and everybody can get access to it. So there is an isolation layer on top of it. Then of course, securing as much as the isolation from the app developer. So it doesn't let the app developer to do deeper stuff than it's needed. So isolating them, making sure that people don't do stupid stuff. And then availability of technology. So aiming to do as much as possible for you as they can. So they have provided something called AZURE IoT Edge Runtime. The AZURE IoT Edge Runtime is responsible to connect to IoT Hub and the device. And the idea is that your devices, instead of directly talking to cloud, they talk to the AZURE IoT Edge Runtime, and the runtime then talks to the cloud. So it's responsible for translating and then connections to make sure that your devices can be done as you want them to be. This provides security, because now if the connection between runtime and cloud is not secure, it's not your issue. Microsoft is going to fix it. They are going to work on that. And because they own the runtime and they own the cloud part, they can do lots of smart stuff there and make sure that that connection is as good as possible. Then multiplexing, making sure that instead of having 3 connections to a cloud, we now only have 1. Then store and forward. So if for some reason the connection to cloud gets broken, the IoT Edge runtime is going to cache the messages and make sure that they are going to keep on going in the future. So let's just say we have a network outage of 2 hours. That doesn't mean that you lose the data for 2 hours. The runtime is going to then send them in the future. And then management for the devices that are not connected to internet otherwise. So in lots of scenarios, we're talking about devices that are old. So if you currently look at how many devices could be internet connected, if you somehow just provide them on connectivity, we're talking about huge number of devices. Most of them have been built in past 20 years. They have some kind of communication channels. If you put AZURE IoT Edge Runtime, you can then connect them to the cloud, and you can then start controlling them from cloud and transferring the data into the cloud. Even though those devices have never been meant to be connected into anything else than one laptop from a service technician. So there is a concept called modules. So the Edge runtime is provided by Microsoft, and it's going to run the modules themselves. So the modules are then adding capabilities. And the idea is that Microsoft produces certain modules, like they have this Modbus, OPC UA, so supporting these translations from different standards to different standards. But all of the other modules are going to be performed and coded by yourself. And each of the module is then performing an action. And the idea is that instead of building like a huge blocks, you're building modules and then chaining them together to do something really smart. Here's an example. We are going to do connect a device that's not able to talk directly to a cloud. So we create a module for protocol ingestion. Then we are creating module for data formatting. And then The data formatting is then sending to Azure IoT Edge runtimes, which talks to the machine learning or whatever we have on the cloud. Why do we want to split it? Why don't we all put protocol ingestion and data formatting in the same container or in the same module? Because if we split them, we can reuse them and we can have multiple teams working on them instead of all of them working on the same thing. The modules are Docker containers. So this is not something that Microsoft came up like, yay, let's do another container or some other way of creating modules. And this is very funny. The first version was not based on Docker containers. The first version was like, oh, we know how to do this well. We know how to invent the new stuff. And it was the new stuff. That was shut down within 3 months. And then they came up like, hey, we heard you guys. It was not a good idea to build our own stuff. We now support containers. What's the interesting thing on the containers? You can, of course, now run your containers with any language. So if the protocol ingestion guys are like, oh, we know Java. We are the best Java guys in the world. Java is our choice of language. They can do it with that. And then data formatting guys, they're like, Python. Have you ever heard about Python? Python is our choice. And then we have two modules. They are different teams, written with different languages, but they can still easily talk to each other and make sure that it works. And of course, any language that you want. That's the easy way to do it. Of course, any language is a little bit misleading. We will get back into that a little bit later.
Are there any public modules which you can use with any of the existing device which will come with it from some company?
So currently, no. So currently, if you want to see the nicest, so IoT Edge was released 3 to 4 months ago to general availability. Before that, it was preview. So it's a super, super new thing. During a build in the USA, Microsoft was demoing DJI drone, the flying drone, running Azure IoT Edge runtime, which is like fully functional Azure IoT Edge runtime that talks to Azure IoT Hub. And then you can write your own modules and run them inside of the drone. So
that should come by end of this year.
Yeah. So that kind of stuff is coming, and there is going to be more and more companies are going to say that if you want to connect or power converters or water pumps or drives or motors, here is the ready-made module for you. Currently, I think there is 20 modules available publicly. I think only 3 of them are written somebody else by Microsoft, other companies. I think GA has written one, and I don't remember 2 others, which companies they've written. But I would expect more and more of these heavy industry companies to contribute ready-made modules for their stuff and their commands and control stuff. That answered your question?
Yeah.
Good. The high-level topology, how it goes, is that you have your customer solution talking to Azure IoT Hub. You can directly connect your IoT devices. So here we are talking about new devices, greenfield devices, not your old devices, but something new, something fancy that can directly talk there. But here we have our Azure IoT Edge. It can be either only the Azure IoT Edge, or we can have as many IoT devices we have. And the other thing that we might have is that we might have a chain of Azure IoT edges that are connected to each other, and then they are connected to an IoT device. Why would we have a chain of those edges? Network separation. So most of the factories have multiple layers of networks, and they're very strict that you cannot just skip from network 1 to network 7. You need to go network 1, 2, 3, 4, 5, 6, and 7. So there is lots of that kind of things for the industry. Little bit about device management. So one of the things that's super hard on Azure, on IoT in generally, is how to manage the device. So how do you know how the device is doing? So of course you have the telemetry. The telemetry is normally just some data, whatever sensor data you have, how is it doing? Then you have commands. So the idea is that whenever device is connected to IoT Hub, you can send commands to the device. So you can tell, hey, start doing this, start doing that, or stop doing that, start doing this. Then you have something called device twin. Some people are talking about virtual twin or virtual device. The idea is that even though if currently our device is not yet connected to cloud like just this second, or that we don't want to go and query how is the device doing, we have a device twin in our IoT hub. And the idea is that it has properties. It has two different properties. It has something called desired. So desired always means that the cloud desires the device that it sets these properties to this. And then it has something called reported, which says that me as a device, I have reported that the properties are this. So in this way, you can always see is that the cloud has commanded the pump to stop. The pump hasn't reported that it has stopped yet. So then we know that even though we have commanded the pump to stop, the pump hasn't yet stopped. Or if we can say that the pump is currently in state stopped, and the cloud is saying, I desire you to start, we can see that we are still trying to get the pump started. And the idea is that if I want to know, for example, which pumps are currently stopped, but should be started, you can query it straight from IoT Hub. And where this is important is that when you start to have a huge number of devices, you cannot just make query to all of the devices. Because getting the results back, doing the retries, doing all of that might take you a very long time. Now you can just do it against the IoT Hub and say like, okay, tell me the states, and you will know them right away. So this becomes very important, especially when you build higher scale solutions. Then you have something called tags. And the tags are meant that I tell on the cloud where is this device, for example, located. Let's just say we have factory, we have 5 levels of floor levels. So we can always say that this device is in floor 1, this device is in floor 2, floor 3, floor 5, and so on. The device doesn't need to know it, because device doesn't really care where it is physically. But your nice app in the cloud, which is drawing the diagrams and showing some kind of UI, cares a lot that I only show in these diagrams the devices that are on level 5 or level 4 or level 3. White tags, so that you don't need to build your own database. Like as we heard in previous talks, building your database is not always flowers and unicorns. It's sometimes real hard work. So taking that out from you. Then the last thing, which is really, really interesting, is methods. So we talked a little bit about debugging and making your experience good. One of the things that people want to do on their IoT things is that they want to call functions, they want to start different kind of methods. So these can be for debugging, they can be for firmware updates, whatever, that kind of things. So you can directly call it from the cloud, and then you can respond back to the cloud what happened. So for example, I can define a method called update firmware. I see that it goes here, it does its thing, it returns back, I succeeded, or it returns back, I did not succeed. And then you can do whatever you wanted. So you can do these kind of things. Then why are the tags and all of those important? Then I can do jobs. So when we're talking about management of IoT devices, only on consumer scenario, you're interested, is my light bulb in bedroom on or off? That's what you're interested. In industrial scale, we're mostly interested, are the light bulbs on floor 1 okay? And if you're talking even more, we're talking about like, are the light bulbs in Finland, all the streets in Finland doing okay? So the scale gets way more larger. So we are not talking about any single devices anymore. We are talking about huge number of devices. And normally we are not talking about all the devices. We are talking about specific group of the devices, but still the one group might be really huge. And what we normally are interested is that what is the desired property, or setting that. And normally how we set it is that either based on reported properties, desired properties, or the calls. And this is how we define it. And two things, we are either want to change the state, or we are interested what is the state. So these two things are supported. And the interesting thing about when we're talking about scale, Azure IoT Hub is meant for scaling that from 1 device to 1 million device. When you go from more than 1 million device, you just need to increase the number of IoT hubs you have, and then you can go up to 100 million devices. if you need to go higher than that, then you should call Microsoft and ask them a little bit help, and they will come and help you to scale even higher than that. And I can tell you there is not many cases in the world where you have currently where you have more than 100 million devices that belong to one company. Because these are not 100 million sensors, these are 100 million devices, and there is a huge difference between those two. So, how this works. Here is our nice devices. They are connected to our Azure IoT Edge, and then we have our IoT Hub. I already told you that they are based on containers, so they are not just random blobs of code. Then it supports a few of the Azure things out of the box. One of the things that you want is that you have now written very nice code in your cloud using Azure functions. You want to take that into the edge. So instead of the data going in the cloud, you want to take it to here. So here we have the device twin, which is synced between them. Then we have the local storage. So each of Azure IoT Edge has a local storage. What's the size of the local storage? That of course depends what's the size of the local storage of the device. So if the device is a rack server, this can be petabytes. If you're talking about something like Raspberry Pi size, this can be a megabytes. So totally depending what kind of edge are we talking. Then it has an Azure Functions runtime. So this is to support whatever Azure functions you want to run. And then it has a container management. So it's currently doing the container management for you. How many of you are familiar with Moby? Few hands, which is very easy. How many are familiar with Docker? So Docker is based on Moby. So Moby is the open source version of Docker. Basically, Docker was the company, and they had a product called Docker. And then their legal team, I think, told them that if you have a name, company named Docker and product named Docker, and you're trying to sell it and also make it open source, this whole thing doesn't really work. So you need to do something with the naming. So they split that. So now there is 3 versions. There is Moby, which is the upstream. And then basically there is 2 other versions, which is Docker Community Edition and Enterprise Edition. Enterprise Edition is always super stable. It's cost you a leg and an arm. I think it's like 5,000 to 6,000 euros per server. So if you have 6 servers, that's a lot of money. If you're talking about IoT and you have 6,000 devices, that will cost you millions and you don't want to buy it. But Docker Enterprise Edition, super stable. If you run production on Docker, might be worth investing. If you're doing IoT, not worth it. Then you have Community Edition. That's basically where all the fancy new stuff land up, and it's living its own life. Then you have Moby, which is meant that if your company is outside of Docker and you want to do something with containers and you want to innovate there, that's the place where you push your code. So currently, if you look at where is the most innovation happening outside of Docker, it's in the Moby repository. And the container management and the container runtime on Azure IoT Edge was originally Docker, but the features that Microsoft wanted to add there was getting pushback from Docker, because they were more like, oh, we are focusing on servers. And Microsoft was like, we are focusing on edges, and we want I/O ports, and we want this kind of stuff. We want to expose more things here. And they a little bit clashed, and so now they're running Moby. Does it really make difference for you? Not really. If you put Docker container there, it runs fine, but it's running Moby, which is sometimes important to know. Then you have different services that are automatically able to run there. So there is Azure Machine Learning, Azure Stream Analytics, Azure Functions, and Azure Cognitive Services. So there are services from Azure where inside of the service you can say, hey, this nice model, take it to my edge. And then the service will package it and deploy the nice module to your Azure IoT Edge. So you can take very easily that there. Why is that important? If you talk to the guys who are doing the machine learning, they are really good at that machine learning service. When you're starting to tell them that, hey, you need to put this inside of container and make sure that it runs there and then deploy it to here using Kubernetes, they're like, do what? I have no idea how to do that. So the idea is that they can just go one click, deployed there, and the whole pipeline is ready-made to do those kind of deployments. The interesting thing is that most companies are using maybe Azure Machine Learning and custom code, or Azure Stream Analytics and custom code. So it's normally like one of the services and the rest is custom, or all of it is custom. So it's not like they're using all of it. Other thing is that there was the device twin, which we were talking about. Other than device, there is also module twin. So then you also know what is the state of the module. Because even though the edge itself might be healthy, it might be doing fine, the module might be saying like, hey, I'm suffering, I'm having issues, I need help, or whatever. Its state is totally different. And each of these modules might have different states. So that's why it's important to know that they have module twins to understand what is their status.
Can you control those from the IoT Hub, like redeploy or change?
So everything is controlled from IoT Hub. So the idea is that there is a CLI. You should never touch it. You go and install the runtime. All the provisioning and all of that is controlled from the cloud. So it's fully managed from the cloud side. You never need to touch it.
So is the point of it is that you do all the processing locally and just push the data, only the data which you would like to have in the cloud?
Yep.
So
Or all of it.
Or all of it. So for example, you have 1 million devices, you would maybe aggregate everything and just send like one piece of information per hour or something like it. So that's the use case for it, to not get like all of the data potentially, but just part of the data what you will decide.
So they support like the number of scenarios is insane. So they support all of them. So one of the ideas is that let's just say we want to build automated water pump, and we want to build some kind of machine learning on top of it. In the beginning, we don't have data, we don't know how to do it. So we connect Azure IoT Edge and we stream all the data to cloud. Now that we have enough data, we create a model here and deploy it here. We can then use the model to provide instant feedback to water pump, but we can still stream all the data. Then one day we decide, okay, we don't anymore need all the data. We can just push an update from cloud, filter the data, that only the data that we want gets into cloud, and then maybe in the future we can also stop like all the sending data to cloud and just let it run there nicely. So the idea is that you only need to deploy this once, because this is a physical, you don't want to do the physical deployments ever again, and then you can change it from the cloud as much as you want. Another thing that's probably coming soon is that companies are only going to have one Azure IoT Edge running in their device, and then they're going to go all vendors and say like, if you want to do something with our physical stuff, you need to run a container inside here, and that's the only way that we are going to do that. Because if you currently go and let's say talk about smart house or smart offices or anything, if you go and tell them, oh, we want to install one more box to you guys, they're like, again, like we have these 100 devices from all different vendors, and they all want to bring their smart box, and the one box is going to solve all of that. What they don't really want those boxes, what they want is your service. If you can deliver your service as part of Azure IoT Edge, if the company already has it, it's more like, it's a one container, push it there, and we can then have your nice service. So that's the whole great and grand idea.
And one more question, like if you have different devices which potentially need to talk to different modules, you need to set up those pipelines within the IoT Edge itself, I think, is it? Because like, I mean, if you have Samsung devices and you use some like a module which reads the data from Samsung device and then like encodes it or whatever, or decodes it, I mean, back and so on, then you have Philips data, they all need to have their own modules there available, and you need to have a, like, define specifically where they connect the devices to each module.
So most of the IoT devices and how it goes is that when the module starts, it goes and shows the network, hey, tell me who you are, and the device is called back to it. Or if you're talking about industrial scenarios, normally the factories have very strict maps. Like they have, these are the IP addresses and they know them beforehand. So in both of those scenarios are pretty common. But normally it's more like, if you're talking about consumer case, it's more like shouting to network and say like, hey, all Philips devices, talk to me. or all Samsung devices talk to me, and then they respond back, and then you can start commanding them. So that's how they normally connect. So depending which scenario you're more focused on there.
Okay.
And normally you don't have one container that talks to both of those, because it's easier to keep them separate, because then you can evolve them with a different cadence from each other.
Can there be a scenario where one manufacturer of some like specific, let's say Philips, actually starts shouting and listening for like Samsung and have a backdoor and push the data somewhere else?
Sure.
Is the IoTH gives you possibility to send the data outside of anywhere else except the IoT hub? Or
So
the only connectivity
currently,
is the
currently by default, all the containers are able to also talk to internet. You can disable that they are not able to talk to internet, and they need to go through the Azure Edge runtime, and then they can only talk to that. So that's all up to you. The same thing is that this is running in some kind of operating system. The batching of the operating system is your responsibility. Secure boot, TPM, all that stuff is your responsibility. Microsoft is not going to take care of that for you. So they're just saying, good luck, have fun.
But there is no any sandboxing itself by default, like providing things.
No, it's a normal
This is what the
Docker. So if you want to do the sandboxing, you can just enable the IP tables firewall rules and do it. They are hopefully going to turn on some kind of like secure edge, like hardening at some point, but it's not yet at least available. I mean, this product is super new. The amount of features is insane. If you currently look, they have a lot of job openings. So if you're interested in making this better, join them. The team was, last time I talked, and they were something like 42 people. Their aim is to go to 200 by end of next year. So if you ask them what kind of features they're going to have, it's going to be massive. I'm super happy about all this product. Like currently it does only this, and each month it's getting more and more nice features. And the nice thing is this is all open source. So the whole runtime, all the services are open source. You can go to GitHub and download it. 70% is in C#, and then 30% is security stuff. Any ideas what language they used for that? Rust. Don't ask me why, I have no idea. They just used Rust to do it. Probably found some really good, smart Rust guys to do it. Performance is also very important for them, so probably also for those reasons. But yeah, so currently, another thing is that when the containers want to talk to each other, by default, there is no ports exposed. You can expose the ports by saying on module between that exposed ports. They talk through the Edge runtime to each other. So they don't talk directly to each other normally. So that's why you don't need to worry about security that much. But of course, you're free to expose them if you want and do all kind of crazy stuff, and then you're responsible for securing them.
yeah, thanks.
Yep. The next thing, programming the module. Currently, there is 5 different languages supported out of the box. So they are C, C#, Java, Python, and Node.js. Why only these 5? When you're talking an IoT hub, the messaging goes through Azure Edge runtime. The Azure Edge runtime, to make it like really work well for you, needs an Azure IoT Hub SDK. The SDK is only available in these 5 languages. So you can basically use any language you want, but then you need to write lots of more custom code yourself. You need to write like all kind of event handling, authentication, a little bit security stuff, and all of those things. In the future, I think there will be more and more languages supported to make this working really nice. Then the hardware. We a little bit touched already on this. So the ability is to run on devices smaller than Raspberry Pi. So normally we're talking something about interactive tier. Then we are talking about industrial tier. And then we are talking about gateways. So gateway is normally something that's installed only to act as a gateway. So those normally look like a real PCs. The industrial stuff, they normally don't even look like a PCs. They're normally like boxes with only Ethernet or only Ethernet and power connector or something like that. They are very strange looking devices which are meant only for very specific scenarios. And then we have interactive tier. There is also sensor and constraint tier. Azure IoT Edge is not meant either of those. And this is also one of the reasons why you will probably never see Azure IoT Edge on your dishwashing machine. Because they normally have something constrained or interactive, something between those two, and they are not going to have a gateway or industrial PC on your dishwashing because they don't need to do that kind of smart stuff. So, if you're a dishwashing company, what are you going to do if you're stuck on constraint tier? There is a new product called Azure Sphere, which is coming soon. They launched it, I think, 3 months ago or something. The first version is coming available next week, so the very first board. And they are board, so you buy a physical device from Microsoft that contains the first ever Linux that Microsoft has made. So it has the own Microsoft Linux. They take care of the all hardware, all the software, and you can only run one application on it, and they take care of all of it. They take care of patching, the whole operating system, all of it, and they only provide the connection to cloud, and you can do your one small little application to control your dishwashing machine. And that's coming to basically extend the Azure IoT Edge here. But like I told you, like all of this stuff is new. That's even newer. It's going to be, like if you physically want it, you can order it today, and they will be start shipping next week. Awesome devices. At least on the pictures, looks nice. They're boring as hell, the devices itself, but you can do smart stuff with it. So, not going to be going there, I don't think ever, but they're going to provide more and other kind of solutions to that level. You need memory. Is this much or a lot memory? Small amount, large amount. If you go to talk to embedded guys, they're going to say like, what the heck? That's insane amount of memory. We will never have that. Too expensive. If you talk about normal cloud or software developers, they're like, oh, how can you use that little memory? So depending. That's why we're not going to see that on the constraint side, because on constraint sides, this is already a lot. Other thing, you need Windows or Linux operating system to run it. So basically you need to be able to run Docker on the software side. Running Docker for most embedded guys is like, way, we never can start running Docker inside here, like never ever. So that's why there is different products for those kind of scenarios. Any questions?
Many.
Good. Sadly, I don't have any nice demos. The service itself is cool. The concepts are cool. It will take you some time to get used to it. If you want to get started, just Google for Azure IoT Edge, start the first sample, install it on your own laptop, install the IoT Hub, connect them. Takes you like 15 minutes, maybe 20 minutes total, and you can start running your modules there and doing all kind of stuff. How cool or interesting it is? Well, how cool or interesting is IoT? If you have nice scenarios, it's super nice. If you don't have any scenarios, it's super boring. Personally, I like it. Been building a lot of things for it for a long time. And I'm super excited about the future because this is very, very beginning. Like this is the first public version of the service. It already provides very nice building blocks, and I'm more interested of like what are they going to build in the future on top of this, because that's when we start to get more and more nicer features. Yes?
I'm not sure I understood one thing. The IoT Hub, is it a special device that you run your software on? And
So that's a cloud component. So it's Azure IoT Hub.
yeah,
So
I mean, is it basically a piece of software that runs in the cloud, or is it a piece of hardware that you need to install into your IP network?
So the Azure IoT Edge is a hardware on your network that you need to install the Azure IoT Edge software on, and the Azure IoT Hub is a service from Azure. Yeah, sorry, I totally skipped that, because of course everybody knows what Azure IoT Hub is. Most people don't, but yeah, I know, sorry. Yes?
So I get that that Azure IoT Edge is like a part of the IoT Hub, what you bring on your own premises and connect your devices to the there. But how about that device that you connect to the there? I understand it's quite easy to create a module to the edge.
Yep.
Where you can discuss with your device. But when you do the upgrade to the device side, you need something there, example to the that kind of things. What kind of stuff you need to the IoT device side so you can get it to the services under that Azure IoT Edge?
So what do you need to have here to do a firmware update, for example?
Yeah.
So first of all, how the firmware update works, because that's a very specific scenario that I've spent quite a lot of time. So you provide the file from IoT Hub to Azure IoT Edge. So the first thing it does, it downloads the firmware to here. Then the firmware gets somehow transferred to here. And that somehow depends a lot on devices. So some devices have that you need to set it on TCP stream, some have web servers or whatever, and then you somehow transfer it here, and then you tell the device, update yourself. And this doesn't spend any time describing how to do any of this stuff. This stuff is like totally up to you. And the interesting thing is that most of the things here are very well known. So if you go talk to the embedded guys, they know exactly how to do firmware updates. They know that you need to have 2 firmwares on the device so that when you do updates, if it doesn't work, you can still restore the backup from the other firmware and all of this kind of stuff. So there is not that much space on innovation there.
Yeah, let's say that this is an interesting topic because bringing that kind of Azure IoT Edge to your own premises, it exactly solved that problem what you described. You can do it also other way.
Yep.
But this is interesting, and I asked that firmware stuff because I have a demo in here about that topic.
Yep. So you connect the Azure IoT Edge here, and then you can start updating them.
This is just a own network in here.
Yep.
So you can bring it to the own premises, and you know that you have normally you have some kind of gateway where your sensors take the connections. Let's turn that gateway upside down and use it to the upgrade to those devices with the dock.
Yep. Sure.
Yeah. But I'm just.
Yeah, this is like.
It's an interesting topic how they are planning to handle it, and yes, exactly that same approach could be used to there what I use it.
Yeah, and I mean, the whole idea is that, I mean, these kind of solutions exist today. I mean, there is nothing fundamentally new on this. The nice thing is that it's packaged completely, and you can get started in 15 minutes, and most of the hard parts are done for you. And the interesting thing in the hard part is like, how do you do certificate management? How do you device provisioning and all of that kind of stuff? Which more comes to like, so this comes very interesting. Like device provisioning is one of those hard things. When you provision the device in factory, how do you install the software on it, and how do you provisioning it after it's connecting in the first time? All of these kind of things are fully managed by the IoT Hub and that kind of things. So, but those things, like, they're super interesting in themselves, but if you don't know how for like those devices are physically manufactured and what kind of challenges you have there, it's not that interesting, but it's a super hard challenge, for example. And that kind of things you get out of the box when you go with this solution.
Have you checked about competition? Does ABS have something similar?
There is, I think, 7 different companies who are providing very similar things. One of the things is that they are mostly very expensive, like the starting cost is very expensive. And other things, they're proprietary. So you cannot change them, like they're not open source, you cannot fork them, and that kind of challenges. But I mean, they are good, and there is lots of production on top of those. There is not that much production on top of this yet. Like this, basically, if you were running production on top of this before 3 months, you were one of the very few companies in the world who were running this. These days there is more, but still very, very few. But the amount of companies that are interested on this concept is insane. So it's a very up and coming technology. And that's why I work with it a lot, so that's why I really, really like it. It's a nice piece of technology. There was one other question. Yes?
Can you make like you mentioned the provision, can you provision also the Docker compose file, like the customer code, the container linked together?
So the Docker compose, no.
So it's used for some scenario, for example, in the Raspberry Pi, you have different containers.
Yeah. So you don't use Docker compose to compose this. You kind of define all the which containers to run and all that configuration in IoT Hub, and it has its own way of like defining it. So it's another way of doing Docker compose, but you know, I don't know, it's not better or worse, it's just different way to do it.
Another orchestration.
Yes, because we need more orchestration in the world.
But Kubernetes is the winner, so how
So the interesting thing on the Kubernetes is that this supports Kubernetes. So you can use Kubernetes to do the orchestration on this. I haven't personally used it. They released that on the build because some people are very used to do the Kubernetes deployment, so you can use Kubernetes to manage this directly.
One question related to these sensors, and like you were mentioning, like what kind of things between the IoT hub and the edge happening. Like what there is the twin, there is the like the like different action and so on, and then you can like trigger something gets instead. So like how you would get the information about if sensor got broken, for example, or there is something wrong with the sensor, like kind of the monitoring of the sensors themselves.
So normally what you do on the sensor is that sensors send heartbeat. And as soon as you lose the heartbeat, you know something wrong happened.
But how, like, so it's good scenario, I think, with the edge case, for example, when you don't really necessarily need to kind of process this edge send it to the IoT app, because it's quite a lot of pollution, like if every 5 seconds, let's say.
No. When we are talking about heartbeat, the heartbeat is normally every 50 or 100 milliseconds. So it's very often. Yeah. So you know exactly the moment that it broke or lost. And yes, you would not want to switch, like send that data to cloud. You only want to send data when you know it's broken. Then you want to send, hey, this device or this sensor got broken. Somebody go and fix it or change it. But you normally do it by heartbeat. So just sending data and then filtering it out on the edge.
Any idea how you would do it without the edge, only with IoT Hub?
So only with IoT Hub.
Yeah.
So IoT Hub has this also heartbeat. So the IoT Hub and the device, when they're connected, sends data over, I think, every second. This kind of heartbeat. So the IoT Hub knows that the device is still connected. Okay. So your device would need to be sending that data. It's not much data because it's an AMQP connection over WebSocket. So one packet is a very small. So even though if you have millions of those, it's not that much data. But when you have 100 millions of them, then it's quite a lot of data just for the heartbeat. Thank you. Hopefully you learned something about IoT and Azure IoT Edge. That was my presentation. Thanks.